Lesson 7.4, 3 types of special parallelograms. Okay, so we're looking at 3 special versions of parallelograms. The first we're going to look at is a rhombus. A rhombus is a 4-sided figure, and we know things are rhombuses if and only if the shape, or it has, 4 congruent sides. So for something to be a rhombus, it must have 4 congruent sides. So as you see here in this diagram, I'm listing 4 sides as being congruent, so therefore it's a rhombus. So if something's a rhombus, then the following things must be true. Okay, so when looking at the diagonals, this theorem tells us something is a rhombus if and only if the diagonals are perpendicular. So just as a reminder, diagonals are the lines connecting the opposite corners, the opposite vertices. And so if the diagonals are perpendicular, then it's a rhombus, if it's also a parallelogram. So what this is saying is if something is a parallelogram and the diagonals of it form a perpendicular lines, then it must be a rhombus. Okay, now let's look at the opposite angles. So a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So what this is saying here is that if I have a diagonal, it's going to bisect a pair of opposite angles. So notice it's bisecting. The diagonal AC is bisecting the big angle A and the big angle C, as well as the diagonal DB is bisecting the big angle B and the big angle D. This is going to come in hand later. The next shape we're going to look at is a rectangle. So a quadrilateral is a rectangle if and only if it has 4 right angles. That seems super simple, but it's important for us to know that in order for something to be a rectangle, it has to have 4 right angles. Now, the diagonal theorem is kind of crazy. So a parallelogram, so notice we know it's a parallelogram, is a rectangle if and only if the diagonals are congruent. So we know that the diagonals bisect each other. We don't know about what angle is created when they bisect each other like rhombuses, but we know that they bisect each other and they form, and the diagonals are congruent. Whoops. Again, we're going to use this later. Okay, now this is the silliest definition. A quadrilateral is a square if and only if it is a rhombus and a rectangle. So all of the properties that were true about rhombuses and all of the properties that were true about rectangles are also going to be true for squares. So let's look at the first property of rhombuses, that it has 4 congruent sides. Now the next property of rectangles is that it has 4 congruent right angles. And you know what? I might change the template here just so it's not as distracting with those grid lines. Much better. Sorry about that. So something is a square if and only if it has a rhombus, so 4 congruent sides, and a rectangle, 4 right angles. But now going further, we can look at the diagonals. So we know that these diagonals are going to be congruent. And we also know that they're going to bisect each other to form 90 degrees. Pretty crazy stuff. Now let's practice. Okay, let's find the measure of the angles in rhombus ABCD. So I have 4 angles here. I know that this is a rhombus, so let's find the measure of angle 1. The measure of angle 1 is 90 degrees, and I know that because the diagonals intersect to form 90 degrees. We don't quite, actually, we do have enough information to find out the measure of angle 2. I want you to think this rhombus is broken up into a little triangle right here. Yes, we can use this to find other properties, but I want you to think if you have a triangle that's 67 degrees, 90 degrees, and there's 2 left over, we can use that to find the little measure here. So I'm going to take 180 and subtract it by the sum of 90 plus 67. And I know that because the measure of angle 1 was 90 degrees. Whoops. Okay, now let's add 90 plus 67. It's 157. Now I'm going to subtract 157 from 180. And I get 23. So the measure of angle 2 is 23 degrees. There's another way we can find that I'm going to look at in just a little bit. The measure of angle 3. So we know that rhombuses bisect the opposite angles. So if 67 is right here, the measure of 3 is also 67 degrees, which means the measure of angle 4 is also 67 degrees. Sorry, I'm getting a little messy here. Oops. Now, if I look at this from the big picture, I want you to think, okay, this is 67 and 67. In total, that's 134 degrees. 134 degrees. I can use what I know about the consecutive interior angles to find the measure of angle D and the measure of angle B, and then we can bisect that. Half of 46 is 2. Now, we're given the lengths of the diagonals in rectangle JKLM. And I know that JL equals 2x minus 6 and KM equals 3/2 x plus 1. So I recommend drawing a picture, but please pause, and I want you to try solving on your own. Okay, let's unpause. So let me show you how I solved this. I drew a picture. Now we can't just place these letters in any which places. You have to put them in order. So I have JKLM. Okay, it doesn't matter where you put them. You could have rearranged the order, but the following things will be true. This tells you, okay, my opposites. Notice J is not next to L, so they're opposites, and K is not next to M, so they're opposites or diagonals. When we set equal to each other, we get X is equal to 14. And then when I substitute that back in, I get JL is equal to 22 units and KM is equal to 22 units. Thank you for watching this video. Have a great day.